for Management 3332. Some learning objectives. We're going to define the term operations management, supply chain management, and very important look at differences between production and service operations, and some of the more important functional areas of organization, and explain how they interrelate. So you can go ahead and read the learning objectives. Let's just go ahead and look at the definition. Operations is an area of business that is responsible for production of goods and services. So that's where actually the product or services are made. So managing that area is very important in organizational success, because that's the core part of any business is its operations. So that's one of the only courses that many business majors may take in their undergraduate business degree, unless they are, supply chain managers, majors. So operations management itself is the management of systems or processes that creates goods and services. And very important to know the difference between goods and services in different dimensions. So as many of you know, goods are just any physical items that has raw material, parts, sub-assemblies, and final products like automobile, computers, oven, etc. Services are activities that provide some combination of time, location, form, or psychological value. So air travel, education, haircut, legal counsel, even restaurants are considered service organizations. In terms of supply chain, that is the sequence of activities that organizations involved in producing and delivering goods and services. So managing the supply chain management has become very important in the past 20 years, mainly because of the globalization. So we see more and more, it's not just a corporation competes with another corporation, more like a supply chain of one industry competes with another. So how effective is supply chain in terms of quality, productivity, reliability, and other measures of performance? So the supply chain is basically the chain that we go through in production of goods and services, and also distribution. So we start with suppliers, direct suppliers, the producers, distributors, and final customers. So this is a process of transforming or transformation process or value-added process that has inputs like land, labor, capital, information, and we go through value-added transformation. That could be assembly of automobiles and computers. It could be making of food in the kitchen of a restaurant. And finally, there's an output of goods and services. And there's always a feedback in order to measure performance. And we have a control area to control all these transformation. So as you see, there's a measurement and feedback that goes into both input, the transformation, and output. Okay, in terms of what we call a good or service, you can take a look at this continuum. And on one extreme, you're looking at a business that is mostly is manufacturing of goods like automobile assembly and steel making. These are mostly like manufacturing goods. Now, as we move to right, we get more services involved with our productions of goods. So home remodeling, retail sales, and then you're looking at computer repair, restaurant meal, and then songwriting, software development. As you see, we're going toward more pure services. And in terms of teaching, surgery, medical services, these are all, pure service. There's not manufacturing any product. It's just pure service. And very important to know differences between manufacturing and services in terms of the following criteria, because understanding the difference between the two help us to better manage either manufacturing or service. Okay, in terms of degree of customer contact, well, services are major in terms of their customer contact. So highly high degree of customer contact for services. Manufacturing, not much traditionally, but that may be changing as we're going toward mass customization of product. Then you see customer interact with the business and actually order their own product. But in general, services have more customer contact. And in terms of uniformity of input, we get more of that in manufacturing, higher uniformity of input for manufacturing, and more variety of input for the services. Because if you think of a legal service or medical service, every patient is different. So there's more variety of input for services. In terms of labor content of the job, well, manufacturing has less labor compared to the services. So I can say, well, manufacturing is capital intensive versus services are labor intensive. Okay, so most manufacturing requires a higher amount of capital, but services is less, and we have more labor in services compared to manufacturing. Same thing for uniformity of output, higher uniformity in manufacturing compared to services. Productive measurement, again, is much easier for manufacturing. Is a little much tougher to measure productivity in services, because services, we're at the mercy of customer arrival, and so sometimes you see that we have less productivity in services because the service takes place with interaction of a business with customers. So if there is no customer, then there is not much productivity. Production and delivery is much easier to manage in manufacturing. Again, for services, totally different story, because the delivery of services depends on the customer arrival. So it's tougher to manage production and delivery in services. Also, we don't have much inventory in services in terms of time cannot be inventoried. So again, services have more issues with regard to production and delivery. Quality assurance, most techniques have been developed for manufacturing, and we are starting to apply more of the quality assurance method for service industry, because, and as you may know, over 70% of the GDP of the United States come from services. So application of quality assurance method for service industry goes a long way in making the production of services more manageable and more reliable, and having higher productivity. Issue of inventory, as I mentioned before, not much inventory in services because the time of the workers cannot be inventory. That's the simplest way I can put it. So, although we have inventory, let's say in restaurants, but if there's no customer in the restaurant, then the waiter is just waiting, and there's nothing for them to do, so you cannot inventory their time. The evaluation of work, again, is much easier in manufacturing compared to services, and the pattern design, again, is much easier for manufacturing compared to service. So why we are studying operations management is because it affects every part of the business. Looking at the functional area or services related to operations, we have financial, marketing, accounting, and information services. All of these services relate to operations, and we talk more about that in the next slide. And by learning about operations and supply chain, we have a better understanding of the world we live in, the dependencies in the global market of companies and nations. Reason for companies to succeed or failure depends on how they manage their supply chain and the importance of teamwork and working with others. So organizations have usually three major functional areas: the marketing, operations, and finance. You all have taken courses in marketing and probably finance, and for some of you, this course may be the only course in operations. So this is how the operations and different functional area and operations overlap. In regard to finance and operations, well, you see the budgeting. You have to budget the expenses, the cost that goes into the operations. Economic analysis of different investments, proposals for, let's say, new facilities, new machinery, new sites, relocating to some other country. All of that requires investment. Provision of funds, how to acquire the funds through issuing stocks or bonds or loan. All of that relates to the finance and operations. Marketing operations relates in terms of operations needs data, and the data most often come from marketing people. That's their job to capture the voice of customers and send the demand data to operations so they can plan for production. In terms of product and service design of the products, again, operations depends on marketing because they are the eyes and the ears of the organization is a marketing group. So they have to actually see what are the trends out there and what product and services the customers demand, and try to help the design group to design the product and then send it to operations for manufacturing. Competitive analysis, that's again done by marketing to help operations do a better job. Lead time data, how long it takes for a product to get to market. That is, how long do we need to send a product to the market? How fast we have to be. If you're first mover, then you need to be get to the market before any other competitors. There are many advantages to that. All right, let's look at there are many career opportunities for supply chain management, and from operations manager to supply chain manager, production analyst, schedule coordinator. So you can list of all of these different areas that your degree in supply chain management helps you to land a job. There are different societies, professional organizations like Association of Operations Managers, American Society for Quality, ASQ is a big one. Myself a member of this one. Institute of Supply Chain Management, same thing here. Operations Research, so PMI, Project Management Institute, that's a big one. If you're planning to be a project manager, you probably need a certification in project management. All right, so let's look at the process management in terms of different processes. There are processes that called upper management processes. This is operation of the entire organization. And the operational process, these are processes that make up the value stream for our value added process. And supporting processes, these are the processes that actually support the main core processes. So you're looking at like human resources is a supporting process. Accounting may be supporting process. IT may be a supporting process for any business. In terms of supply and demand, we like to have a close match between the supply or our capacity to produce product and the demand in the market. So if we have high capacity, so if we have high supply compared to our demand for the product, then we're producing too many products that are sitting there. So that's a wasteful and very costly. If our supply is less than demand, then there's opportunity loss. What we're losing by not selling our product. We don't have enough product to sell. And that in the long run results in a customer dissatisfaction because, customer depends on us. And if we don't have enough product for them, they probably seek other competitors and they may just leave, and we lose the business to competition. So the ideal situation is to have a good match between supply and demand of our products. So there are variations. Variations factor life in, basically anything we do, any product we make, they're all different. So there are a variety of goods or services being offered. So as you see, many auto industry and auto companies trying to have all different type of automobiles. That way, if a person is, let's say, is a Lexus customer and they always buy Lexus, then they have the full range of different products to choose from. The same thing goes with Ford and GM and Toyota. Every car company tries to keep their customers as customers age from 18 to 65, 70 or 80 years old. So they like to have products that fits their lifestyle from the day they get driver's license until they retire. So the variety is very important to keep the customers you have and be loyal to your customers. That way the customers are loyal to your product and services. There are structural variation. These are predictable, important for capacity planning. So structural variations are like a trend in the demand for product or seasonality. For example, the demand for gasoline is highly seasonal. So you have a high demand in summer and lower in the winter. Or there's a trend, a gradual increase in demand for, let's say, electricity in a given country. A random variation is the variation that basically exists in every process. Okay, you cannot really hard to predict it, but we know what the random variation is. We can't get rid of the random variation unless we make a major design change in our system, and that's usually very costly. So random variation or common cause variation always exists in any process. So we're not really much worried about that because it's very hard to move the random variation. But assignable variation, that is a variation that has some specific causes. So let's say there's a part on the machine that's broke that results in the output to be, off, in terms of its size and dimension. Okay, so a standard variation has many causes, from faulty raw material, faulty process, faulty design. All of that results in major variation that usually results in poor quality. The scope of operations management range across the organization. We do the following activities in regarding to operations function. So the forecasting, that's an art and science of predicting future events. That is very quantitative chapter that we're going to cover. That's chapter 3. A lot of homework in this chapter, and major part of the first test, the problems come from chapter 3, which is forecasting. Capacity planning, that is chapter 6, in terms of figuring out, how much capacity we have to have in order to meet the demand. Facilities and layout, and scheduling, also managing inventory. That's chapter 13. That's another, quantitative chapter. Quality assurance, that's chapter 9 and chapter 10. Motivating employees, we're not going to get into that much. So, and deciding where to locate, that is location decision analysis, and that's in chapter 8. So operations manager role is consists of all activities directly related to production of goods and services. So we have to deal with decision making in regard to system design decision and system operations decision. Now, what's a system design decision? In terms of, okay, this is usually come before you start your, let's say, manufacturing. You have to decide on your capacity. So if you have designing a new refinery, you have to be able to, okay, this is going to be a refinery or chemical plant that's able to process 50,000 barrels or liters per day. So that's capacity. When you're, designing a new restaurant, well, the number of seats you have in the restaurant basically determines the capacity of a restaurant. So those are original decisions made in the design of or the system. Also, where to locate, facility location, and there are many components that goes into figuring out where to locate, and we'll get into that in chapter 8. Facility layout is more, how we're going to go ahead and do this manufacturing operation, and there are different layouts possible for doing that, and planning your production and service, and acquisition and replacement of equipment. And most of these decisions are strategic decisions. By strategic, we mean long-term commitment of resources. Okay, so we have strategic versus tactical. So if you don't know the difference, strategic is long-term, tactical is usually short-term. Okay, systems, operations decision. These are tactical and operational decision, like management of a personnel, how many workers do we need, their pay, their motivations, inventory management and control, scheduling, project management, quality assurance. These are all system operations decisions. So in terms of decision making, these are the following operations decision: what, when, where, how, and who. What are the resources we need, and in what amount? When will the resources be needed? When should the work be scheduled? Where will the work be done? How the work will the product be designed? And who will do the work? So these are all operations decisions. Using a model. Model is abstraction of reality. You can have like a mathematical model to simplify real world interactions. So we use a lot of model like
Such a
inventory
cute,
model,
yeah.
forecasting model, and so the model helps us to make decision even before we start the production. So you'll see a lot of computer-aided design and modeling is done on, let's say, design of aircraft. So when 770 Boeing designed 777, the whole airplane was designed on a computer. So they could change different factors and components and see how it affects the reliability of the airplane or the wings and different part of the. So it's their use of model makes our job much easier. Is makes the design of the product much less costly, and we're not going to get away from the models. Although they may have some problem in terms of they're not exactly right, but for our purposes of making decision, it goes along with helping operations managers. And in order to use the model, you have to know the purpose of the model, how it's used, and so on. And here's the benefit of the model: easier to use, less expensive, requires you to organize, sometimes quantify information. It helps us understand the problem. It helps us to do what-if questions. If we change this, what happens to that? So it's a tool for evaluation and provide a standardized format for analyzing problems and enable users to bring the power of mathematics to bear on problems. And it has own limitation. It has a risk of widespread availability of sophisticated computers model are placed in the hands of uninformed users. So it may be used incorrectly. Just because a model says something, that doesn't mean it's correct. So you have to understand the input into the model. So input must be right, and the model must be approximately correct in order for us to be able to understand and accept the decision made by the model. And it just does not guarantee a good decision every time we use models. So the quantitative approaches we're using, many of these methods have been developed in the past 100 years, like linear programming was developed in the 1940s, mostly for optimization purposes. Queuing techniques developed in the 1900s, and mostly for managing the queues for telephone switchboard. That's where the origin of the waiting line management and queuing theory was. The inventory model, the same thing in the 1950s. Project model like CPM and PERT developed in the 50s and 60s. Forecasting techniques, we've been dealing with forecasting techniques for the past 300 years. So some of our methods like regression goes back to 1800. And same thing with the statistical model, it goes, different method goes back 200-300 years. So in this class, we cover a chapter on queuing techniques, that's chapter 18, inventory models, that's chapter 13, project model, chapter 17, forecasting, we cover it in chapter 3, and statistical models, we cover in chapter 10. Okay, we're going to skip this one, trade-offs in terms of matrix and trade-off, and systematic approach. I was going to skip that. Priorities. Pareto phenomenon. It's very important for you to know what's the Pareto phenomenon is. A few factors account for high percentage of occurrence of some events. So the critical factor should receive the highest priority, and concept that's approximately applied to all areas and level of management. So Pareto phenomenon, or Pareto chart you may have heard of, Pareto is an Italian economist that first used this concept on looking at the wealth of a people in Milan or one of those Italian cities, and figure out that a very small portion of the population in that city actually has the majority of the wealth. So few people. That's pretty much the way we have in this country and most countries like that. The very rich, a few of them, and they own majority of the share. So let's say the top 5% of richest people in this country own 90% of the wealth. Okay, and that shows uneven distribution of wealth. The best you can do, probably, if you look at some socialist country, the difference between income is much less compared to United States, and that's mostly due to high taxation. So very rich people have high taxation, and that's how socialist countries take away from the very rich and distribute it to the society. So the Pareto chart, critical few and trivial many or important many, was coined by the quality guru, Dr. Joseph Juran. And basically, in terms of quality, they realized that a few problem causes majority of the issues, or few people cause majority of the complaints. So if there's a problem with, let's say, few items or few, if you're looking at, let's say, for an airline, looking at the complaint, you may look at the complaints coming from many different type, but maybe arrival departure delay and the luggage lost and poor food, they may be the major ones. So if you got arrival departure delay as the one with the highest percentage of complaint, that is a critical few, one of the critical few factors. Okay, that results in the high percentage of complaint. So know about critical few and trivial many, or later we named it important many, and that's basically to divide our critical factor into the very important ones and not very important factors. Historical evolution of operations management, starting from Industrial Revolution, scientific management, human relation management, decision models, and influence of Japanese manufacturing. I'm just going to go over this very quickly. If we go back to pre-industrial revolution, the age of crafts production, the system was, this is like 1400, 1500 Europe. The Wesley has mostly skilled workers. They use simple tools to produce small quantities of customized goods. So you had a carpenter, a shoemaker, and the person was in charge of himself. Maybe an assistant made the product, and they basically sold it in the market, the local market themselves. But we have some key issues or elements that provided us the era of Industrial Revolution. The revolution started in 1770s with the major reason for that is the steam engine. The invention of a steam engine. Basically, for the first time, we could harness the power of machine. Before a steam engine, we used muscle power, manpower, or manpower, animal power to do the work. But the steam engine brought us the power of machines to do the work. Also, division of labor by Adam Smith. You probably had that in your economics classes. Basically, Adam Smith says, if we have division of labor, that is the most efficient way of doing the work, a specialization of the work, and then for the work you do, you have compensation and use your compensation to buy other service and products. Other major development are cut engine and interchangeable parts, and that is credited to Eli Whitney. And for the first time, we see the application of interchangeable parts was in this country by Eli Whitney, and they borrowed the idea, which did not really took track in France in production of muskets, but Eli Whitney took that idea, and the first what we call the contract by Defense Department, it used to be called the War Department in the 1700s, and they got an order for 10,000 muskets, and they were supposed to deliver in 2 years, and it took him 10 years because of the variability, too much variation in size of the parts of the muskets. So it has a longest, colorful history on how Eli Whitney took the idea from French gunsmith by name of Honor LeBlanc and applied it to make muskets in this country. Let's see, scientific management, very important. Frederick Winslow Taylor, he is called the father of scientific management. He applied scientific method to increase efficiency of the work. And he believed in scientific management based on observation, measurement, analysis, and improvement of work methods and economic incentives. Basically, he believed that management knows the best, which in that time may be the case, but because most of the workers, let's say in 1900, had no education. So they basically had to be told what to do in terms of how to do the work. So he said that management is responsible for planning and selecting, training workers and finding the best way to perform each job. And the worker's job is just to do the work, do the execution of the work. So the emphasis was on maximizing output. If you have time, take a look at Frederick Winslow Taylor and how much is his contribution to operations management. So if you go back to like the Japanese manufacturing system of 1940s and 50s, their Bible in their production system is a book written by Frederick Winslow Taylor, because he was the first person that really applied scientific method in improving work, increasing quality, increasing productivity. All of that goes to Frederick Winslow Taylor. Human resource movement or human relation movement, how important are the human factor in production, and application of psychology in the work. Lillian Gilbreth and Elton Mayo, and Hawthorne studies on motivation. You may have heard of Hawthorne effect. Hawthorne was the name of a factory, and they were testing to see if changing the work condition actually results in change in productivity. And they realized that, as they changed in this factory, they were studying the workers. and they were changing the temperature and lighting, and they were expecting that with better lighting and better, nicer temperature, there's going to be higher productivity. Well, that wasn't the case, because no matter what they did, the productivity was high. And they were just baffled why we don't see an effect in productivity when we're changing the environmental factors. Well, the reason was the workers knew they were under observation, and because of that, their performance was very good, because they knew they were being watched. So here then, attention to people becomes more important for improving productivity. Maslow motivation theory, or hierarchy of need, you had this in your first management class. Two-factor theory by Hertzberg and McGregor, theory X and Y, and Uchi theory Z of 1981. These are different theories for motivation. Other contributors, F.W. Harris, 1915 actually, their study of mathematical model for inventory management, and Dodge and Roming and Schuhart using a statistical procedure for sampling and quality control. Tippett, sampling theory, operations research, OR group, originally started during the Second World War, and basically U.S. government hired many scientists, mathematicians, physicists, psychologists, sociologists, and they just put them under one roof, and they just gave problems to them to solve. So many of the military intelligence application, all of that in the Second World War was basically were designed and planned by the Operations Research Group. George Dancing, the application of linear programming, 1947, that's for optimization of the systems. The very important factor in operations is the influence of Japanese manufacturing. If you look at the Japanese economy before the Second World War, basically made in Japan was synonymous with shoddy, defective, poor quality products. And after the war, all of a sudden, the Japanese became the major manufacturer of high quality products. So how all of that happened? I mean, what changed in the Japanese mentality or the situation they were in to go from a country that really was very poor, agricultural, rural country to one of the most industrial countries in the world with the highest productivity and highest quality? Well, guess what? They started quality revolution in the 1950s, and most of that actually goes credited to people at Toyota. So in terms of a higher quality of production, the Toyota system, or Toyota production system, is the most highest quality manufacturing in the auto industry. Just-in-time manufacturing and just-in-time production, all of that was developed at Toyota by Teiichi Uno in the 1950s. And Mr. Uno on his own is one character that we need to actually study more, because he made major contribution to the field of lean manufacturing and just-in-time production. And his work was because the Toyota culture of do it yourself, and we're going to develop it ourselves. So the mentality at Toyota cultivated this concept of, we're going to do it ourselves. We're not going to depend on others. And it took Ono pretty much about 12 years to develop and master the concept of just-in-time production. Other issues for managers, economic condition, innovation, quality, risk, and competing in global economy. Environmental concern, you pretty much know about that. I'm not going to get much into sustainability. Most of you know what's that all about. The ethical issues, the same thing. And we need supply chain management because oscillating inventory level, inventory stockhouse, late deliveries. There are a lot of issues that we may see in supply chain, and supply management can address these issues. So need to improve operations, increase level of outsourcing. As you see, we have more and more outsourcing going on all over the world because it's more efficient. Increasing transportation costs is another issue, especially if you're transporting, a higher size, bigger, bulky items. Much more competitive pressure, higher globalization, more and more importance of e-business, more complex supply chain, and need to manage inventory. So that's it for chapter 1. So you can now go ahead and work the homework in chapter 1 that's assigned on Connect. Thank you very much.